right. You know what that song means. It's time for another cool math video. Rock stars, thanks for coming out. We are going to be talking about subtracting fractions. We're going to hop into a little bit of that mixed improper as well. What is taken before you get it? Taken. Your picture. Snap. Right. I see you laughing. I don't blame you. It's good stuff. All right, let's dive in. So today we're going to be subtracting fractions, just kind of a basic overall understanding of what it means to subtract fractions. We're going to talk about some crazy animals in the process. Let's go. Let's see what happens. All right. So just some of the keys to subtracting fractions are cats, dogs, and cows. If you watched my adding fractions video, you know all about these cats, dogs, and cows, and it's pretty much the same thing for this video, but let's see. We're going to talk about what does the whole represent in the problem, okay? So we'll understand why we can't add cats, dogs, or subtract cats and dogs. And then we're going to simplify, just a key part of fractions. So we're going to make sure we solidify that today in this video. All right. Okay. We can only subtract things that are the same things. For example, I can't say I have 9 cats, and then I take away 3 dogs and get 6 cogs or 6 dats. You can't take dogs away from cats, and you can't take cats away from dogs. So in other words, when you're subtracting fractions, they have to be the same thing. They have to either all be cats or they have to all be dogs. But more importantly, and when we're talking about fractions, they have to be the same denominator, which means they have to be the same number. So in this one, I can't subtract 12ths from fourths, or I can't subtract fourths from 12ths because they're different size shapes. They represent a different value. Thinking about what the whole represents in this first one, it represents a pizza cut into 4 slices maybe, and this one has a pizza that has it cut into 12 slices. So we can't take a 12 away from a 4 because they're different size shapes, just like cats and dogs are different thingamabobbers. So let's go ahead and try a couple. All right, so for this first one, this is like the most easy and basic sense of what it means to subtract fractions. So I have 6/8 minus 1/8. So I have either they're all cats or they're all dogs. They're the same denominator, which means I just simply subtract. I keep the denominator because I had 6 of them, and then I took 1 away. So I have 5 now. 5 what? 8ths, because that's what I'm adding or subtracting. Those are the things I'm dealing with. So that's it. Then you look at it and say, can I simplify it? In other words, you take your top number and you say what numbers, what are the times tables that go in to make a 5, or what multiplies together to make a 5? Well, it's 1 and 5. So 1 times 5. Is there anything else I can multiply together to get 5 that are whole numbers and not decimals or fractions? Nope, that's it. What about 8? Well, we know 1 and 8. So 1 will work with everything, right? 1 times itself always works. It's an even number, so we know 2 will work. So 2 times what is 8? 4. And the only number in the middle is 3. Will 3 go into 8? No, it will not. So when you do this, you look and say, do I have any common factors besides 1? I don't have an 8 on the top. I don't have a 5 on the bottom. I don't have a 4 on the top. I don't have it. So it's already simplified. If there's nothing in common, leave him alone. He's good to go. All right, so let's look at this one. I have 3/4 and I take away 1/8. Uh-oh. I can't take dogs away from cats and I can't take cats away from dogs. So we have to find something that they have in common. So the first thing you ask yourself is, will the smaller number go in to the bigger number? And if it's yes, then you can switch them both into the bigger number. So yes, 4 will go into 8. So let's leave 1/8 alone because it's going to stay the same. But we're going to take this top one and cut it into 8ths instead of 4ths. So what did I do to get to the 4 to the 8th? Basically, we're making an equivalent fraction, right? Which means whatever I do to the bottom, I have to do to the top. So 4 times 2 equals 8. So if I did that to the bottom, I must do that to the top. 3 times 2 is what? 6. I have 6 of these 8ths, and I'm taking away 1 of these 8ths. So what do I have? I have 5/8. Okay, and this is the same answer as the last one, so we don't need to go up here and show what the multiples are because we know there's nothing that will go into a 5 that will also go into an 8. So that is our final answer. All right, let's look at another one. 4/5 minus 1/3. Red alert! The denominators are different. So, will the smaller number, will 3 go into 5? It will not. So now we have to find a cow. We can't turn the cats into dogs, and we can't turn the dogs into cats. So now we have to find that third animal, which is a cow. So here's what I do. I take my smaller denominator, in this case is 3, and I do the multiples of 3 and up to about 5 times. And hopefully, normally that's enough. So if I take 3 and I count by 3, 3, 6, 9, 12, 15, right? Then I say, let's take the other denominator and count by it. And as soon as I see a number that they both have in common, that's my cow. Let's count by 5s. 5, 10, 15. Moo! I got 15s in both. So now we're going to go in here and change these into both into 15. And otherwise, we're going to find equivalent fractions that work for both of these so that now we can subtract like denominators. So we ask ourselves in the first one, what did I do to the 3 to get to the 5? I multiplied by 5. And if I multiplied the bottom by 5, I have to multiply the top by 5. What is 1 times 5? That's right, it's 5. Then what did I do to the bottom here to get to this equivalent fraction? Well, I multiplied the bottom by 3, which means I have to multiply the top by 3. What is 4 groups of 3? That's right, it is 12. So now I have 12 of these 15ths, and I want to lose 5 of these 15ths or take them away so we can subtract. What's 12 minus 5? Well, that would be 7. And what's the denominator? It stays the same. So now we just got to make sure we can't simplify. We got a 7 on the top. 1 times 7 are the only factors of 7 because nothing else will go into 7. Will that 7 go into the 15? No, it will not. So we are already simplified. Here we go. 9/8 minus 1/4. Oh, we got an improper fraction on top. Nothing changes. We still do the same thing. And then we may have to change something in the answer, but maybe not. Can we, so the process right here is the same thing. Do we have all cats? Nope. Do we have all dogs? Nope. Do we see how the smaller denominator will go into the bigger denominator? Yes. 4 will go into 8. So we are going to turn these into 8s. This one, we don't have to do anything. We just write it over. What did I do to get from the 4 to the 8? I multiplied by 2, which means I got to do the same to the top. 1 times 2 is 2. All right. Now we've got common denominators, so we can just subtract. What is 9 minus 2? It is 7. And we keep our denominator. Okay? The only factors of 7 are 1 and 7. Will 7 go into 8? It will not. We are simplified. All right? What about when we have a mixed number? All right? Don't worry. So when we have a mixed number, we don't really pay attention to these numbers, the whole numbers yet. Let's just go ahead and deal with what we have on the other side. And we may have to deal with the whole number, but let's just take a look. So we have cats and we have dogs, and they will not, the 2 will not go into the 3. So now we have to find a cow. So take your smaller denominator, 2, and count by 2s. 2, 4, 6, 8, 10. Remember, just do about 5 of them. You may have to do more, but just do about 5. Then we take the 3s right underneath it and go 3, 6, moo. Now we got our cow. So now we have our new denominators. Okay, let's put them up there and let's find our equivalent fractions. What did I do to get from the 3 to the 6? I multiplied by 2. What do I do from the top? I multiply by 2. What's 2 times 2? It's 4. Okay, what did I do to get from the 2 to the 6? I multiplied by 3. What do I have to do to the top? I multiply by 3. And I get 3, 6. Okay, pretty simple. What is 3, 6 minus 4, 6? Uh-oh, can't do that. I can't take 4 away from 3. So we have to do just like we would in a normal subtraction problem. So let's say we had 43 minus 34. If I can't subtract this 4 from the 3, what do I have to do? I have to go next door and borrow in a normal subtraction problem, right? So I would say I turn this 4 into a 3. And since I borrowed it, there would be a 1 over here. So now it would be 13 minus 4. It's the same concept in subtraction of fractions, but there's just one little difference, okay? So we're not just going to move a 1. We're not going to take this 4 and put a 1 over by this 3. Okay, that's not how that works. So what we have to do is go in and we got to take a whole away from the 4. So when we take 1 away, yes, this is still going to turn into a 3. This is going to be a 3. But we took a whole away. And what is our whole in these fractions? Well, it's the fractions cut into 6. And what is 1 whole if we cut it into 6 pieces? Well, we took a whole away, so we took away 6, 6. We moved a whole over to here. Now I just have to take that whole and add it to the fraction I already had. What is 3, 6 plus 6, 6? Well, it is 9, 6. Okay, now we can subtract. What's 9 minus 4? 5. What's our denominator? They were both in common, so it stays the same. Then we come over here and say, what's 3 minus 3? Well, that's 0. So this is our final answer. Just got to make sure we can't simplify. 5, the only factors that will go into the smaller number is 1 and 5 will not go into 6. So that is our final answer. Pretty cool, huh? Told you guys. Subtracting fractions is the cat's meow. What has no fingers but has many rings? No fingers, many rings. Oh, that would be a tree. You know, because like if you cut down a tree and you look inside, it's got all these rings and it's got no fingers. But that would just be weird if it had fingers. Yeah, that would be weird.